So, welcome to this tutorial. We're going to make a chair. We'll show you first some reference images. They are all drawings actually. So here you can see the triangular shaped chair. We're going to make that one, not a square one like in this image, but a triangle one. You can see it here also. On all the paintings and drawings, they are always the same simple shape. So here we're going to make the one with the support for the back, like there on the left. So here there is one on the right, another one with the support for the back. They're sometimes a little bit different, the support for the back, but no, it's not so different. So we're going to look for the best one, and we're going to use this image as our sample to work on. So we put this on my second screen here on the left. You don't see that, but it's very important to always work with your reference image somewhere next to you, that you can always see that while you're modeling. Because yeah, if you don't see it, you don't actually know if you're doing it correct or not. So we start from a basic cube, remove an edge. Now we have already a triangle, and now it's a matter of making them the same size, every side of it the same. So we're going to enable the length information, and now when we grab it we can see the length of every edge. So this is very easy then to make it the same. So I will not explain the very basics of Blender, like how to go to vertex mode, polygon mode. I think there are other tutorials for that. But once you know the very basics of Blender, you can follow easily, I think, this tutorial. So we're going to reset this position of the object to the center of our scene, rotate it so that it's more or less symmetrical. It's easier to work on. So of course the support of the chair has a thickness, it's made out of wood. So we're going to put it to metric units, that's so in meters in this case. So it's always very important to work with the correct units and also the dimensions that you can see on the right. Start always with the correct dimension, because otherwise later it will give problems. I'm going to add the legs. Try to reduce the polygons as much as possible so that it's very easy to edit afterwards. The more complex you start your model with, the more complex it will go further on. What is very important if you model in Blender is think about instances. So if you have 3 legs or 2 legs and these ones will be more or less the same, then just instance duplicate it such a way that if you change one, the other one will be identical. It will change also. So this one we will instance duplicate. The other one is for the back support, so that one is not an instance. So like you see here, both of them they change when you change only one. So instances is something very important. Don't worry about the very low polygon. Even when we make a very high quality model, always start with this very simple shape and then slowly add more edges and detail and scaling and extruding until you have your more or less final model. And then you start adding subdivision modifiers, which will add polygons on your model so that it will look more high resolution. But that's for later. So this is how it looks when the polygons are smoothed. Now we're going to think how to make the sphere on top of the leg. I think it is connected with the leg so that it's made out of one model. So I'm going to actually also model it in one and not a separate sphere and then a cylinder, but just connect it with each other. Then when you smooth it later on, it will be a nice one-shaped object. So, but then I don't know how a sphere looks like, so I'm going to put one behind it so that I can see if my model is correct, and if not, to change it to make it more look like a sphere. So modeling is really, it's most of the time not so complex. It's just a matter of starting with a clean shape and then adding slowly detail. Now we're going to make the support for the back. Every object has its local coordinates, so now I'm scaling in the local Z, translating it to the local Z. So once you orientate an object, it has an orientation. And on that base you can scale it, grab it, etc. So you have also the world axis, which is always the same. So now it's in the world axis. But most of the time you will use a local coordinates maneuver. The support for the back itself is curved, so it's a bit more complex. So I start with just a simple rectangle. Then we will subdivide it, add some edges so that it can make it look curved. We grab our model with the kind of brush edit, and what it can do is it works actually via a kind of curve, and if you translate something in the middle, everything in the circle it will also translate, but then in a curved way. So the object you grabbed or scaled will be 100%, and all the rest will be a percentage of that, also scaling with it, so that you can make easily smooth curves. So the thickness, we add a solidify modifier. It's always important to reset the scale to 111, because if you don't do that and you add a modifier like a thickness and you add 1 centimeter, it will not be 1 centimeter. It will be multiplied by the scale. So if you reset the scale, that's important, because then afterwards your modifiers will be correct in terms of dimensions. If you use a modifier, then you can always collapse it later on to continue working on it. So actually I was wrong, it was not following the triangle, but it's actually following, starting from the both ends of the vertical legs. So it's a little bit of a weird kind of shape, but that's the way it works. I'm not going to explain everything what I do here, because once you know the basic movements, it's just a question of modeling until you're happy with the basic shape. So the mistake that a lot of people make is that they just model an object with straight lines, apart from some really exceptional cases, nothing is really straight in this world. So everything has some kind of curving or yeah, extrusions of parts. Um, so try to avoid just 100% straight lines, especially also for this chair. That's not mechanically made, so it's just all handmade things from yeah, hundreds of years ago. So don't make it look like it's made out of a machine. Sometimes you will be yeah, working a long time on something very simple just to yeah, match it exactly like it is in the real life. So now we're going to add the extrusions that you can see on the drawings here. We're going to bevel them, add another edge so that we can later on scale that and make our basic shape. Now we select all the inner parts, scale them locally on their X and Y axis, and voila, we have a very simple ornamental site. We just instance duplicate this one, drag it and position it correctly. So now that we have this, I think it's time to save this object. It's always important to save from time to time your Blender object because yeah, if you do something wrong you can always return back to an older model. So this is very important that you save regularly. Also when you do something complex, always save it before. So this, we add a subdivision here. So I told you before, a subdivision it subdivides the polygons depending on the number that you put in. In this case we subdivide 2 times. So now we're going for the high resolution model first. So we made a very basic shape, then we add subdivision, and now we're going to add more detail. So the closer polygon edges are together, the sharper your edge will be. If the edges are very far from each other, it will become a more smooth, rounded mesh. What is also very important is try to always make quads, so not triangles but 4 points, because the subdivision modifier can deal with that. It every time subdivides it in another polygon with 4 points, but if you don't do that you will create ugly meshes. So like you see here, I added an edge very close, and it's a sharper edge. So it's a part from the wood where it has been cut, so it needs to be sharper. And I will do this with every object, every part of this chair. I will add a subdivision modifier and then add more edges to create hard or soft transitions. I will just select all of them, add the subdivision modifier, add close edges where it needs to be sharp. Still don't overdo it, try to keep it as simple as possible. Mostly when you have sharp edges you need to do it horizontal and vertically, so that you don't have a sharp edge in only one direction. Now the next thing is we have to add a kind of curve in this support. By rotating it, it doesn't look like it is actually rotated, but more like the middle is translated upwards without rotating the full object. So we're going to just add the curving modifier and then we just grab it up, and in that way we can create easily this curve, but still the ends look a bit rotated because they have to connect with the other supports. So by making the circle larger or smaller, you change the curving. That looks more like it. Now we're going to this doesn't look so great because when edges are not close to each other, it will try to smooth as much as possible. So by adding already more horizontal edges, you see already it becomes sharper horizontally. But now the most difficult thing will be the vertical sharpness. So try how we can able to fix this. I'll just bevel this, and then you see it's already not becoming a sphere anymore. This is already much better. But now we don't have nice squares anymore. You see it has more than 4 vertices. First we're going to inset it to have some sharp edges on the bottom also and on the top. So this is the result. But the edges on the corners are still not sharp enough, so we're going to add some more edges in every side. And once you've done that, once you're happy with it, you should try to clean up and make from everything squares or rectangles. So you need to analyze the model a bit. How can you connect things with each other, edges, vertices, so that you can come up with a clean mesh, because the subdivisions modifier needs that. Sometimes when it's really not visible, you don't need to do it, but in this case it's very visible. So now in every corner we just connect it with the other side, the middle of the other side. Voila, that's already a bit cleaner. So now there should be all squares on this object. Now we're going to finish up the sides. So high polygon modeling is actually still low poly modeling with some modifiers on top of it, if you can. So this is always the ideal situation, because you see once you have low polygons, it's easy to change things. Imagine if you would now collapse these polygons that you see in the wireframe. It will be so difficult to still change things because there are like hundreds of vertices in a small part of the object. So that will become easily a mess. Now it's a question of finalizing the parts. Here and there we have still some problems. For example, the ornamental parts, they're now smoothed out because we did the subdivision surface modifier, but we will add some edges later on so that also these will look correct and sharp. But sometimes you have to try it and see, and if it doesn't work, yeah, you just go backwards. It's a trial and error sometimes. You don't always have it immediately from the first moment you model it that it's correct. For example, here the sphere connected to the cylinder was too smooth, so we added there as an edge. Also here we will have to add some edges. That already looks better. The bottom parts are not completely sharp, so it's a bit curved. So I don't add too close the edges. Again, here we make quads from the bottom. Voila. The same thing here. Scale this, try to find the local scaling of the three of them. Here it went a little bit wrong. So I guess I need to bevel this to make it a harder edge. Now, of course, the sides of the triangular plank is not done yet, so we're going to make that now. Also, yes, the bottom parts still need to be done, so we're going to make that first. So trying to align this with the triangular shape. Make it smooth. Add already the edges on the end, that it will be sharper there. We isolate our selection so that we only see this object, and then we can continue editing it, and later on we unisolate the object and then we can continue with the rest. So this is a way of easy modeling one part without seeing the other objects. So now we copy the modifier of the vertical leg so that we don't need to look for it anymore. We can just copy modifiers from existing objects, models. Connect them to the edges. So this one looks fine. Now we can just instance duplicate that one. Also for the other sides. You can rotate it 180 degrees or mirror it. Later on we will add some deformation to all of them individually so that they don't look duplicated. That's also important because yeah, if you see objects which are duplicated or they are mirrored, you notice that very fast, and that's not like it is in the real world. So you can always instance duplicate it in the beginning, but on the end, when you finalize it, make it look still a bit different. Now the final part is adding the ones around the triangular shape. We're going to locally scale all of them individually in the X and Y axis, and then scale them in the local Z axis so that they fit between the vertical supports of the chair. So this is already a good model. Let's scale this plank a bit because it was a bit too thick. Like that. Let's save it. Also incremental saving. So that's that. Let's do some very small details. Sometimes you can continue working on a model for hours, but at some point you need to say, okay, this is this looks good. There's no mistakes in this model, so we continue working on this. UVB mapping, texturing, and then convert it to low poly. I will still add some small adjustments. For example, the sphere is a little bit smaller on the ends, so I will scale that down a bit. So now that I'm adjusting this, I will explain what we will do next. We will UV map the objects, which means every vertex has an XY coordinate to be able to apply a texture on it. So it's just an image layout, so that you can also give it normal mapping, specular mapping, reflection, etc. So you need to unfold everything on a plane, and then later on you can give it color. So what we do here is we select the edge that we want to, and we mark the seam. Mark seam in Blender means you will later on unfold this so that it becomes flat. I will just do some finalizing here because we didn't make this polygon. Weld this one together because there were 2 points. Okay, so you see the red line, that's the line that has the seam to unfold this object. First, this also needs to be a quad. Okay. So this is now ready to UV unpelt. But we will just continue first with the other ones. So you need to think what is the best way to unfold this into a plane. So you always need to think the edges that you select, it will be opened there and it will unfold onto a flat surface. So I'll show you an example. Look, for example, here on the left. This is our UV layout, and this is the result. So the red line splits the objects into separate elements. So now later on we can give this a texture. But let's just remove this out of our main texture, because we have a lot of separate elements, and if you would all UV map them in the middle of our UV map, they will be on top of each other, so it's good to all just drag them out once you UV map them. And then later on we can attach them into one single object, which is good for performance if we use this later on in a low polygon game also. So we just check if the directions are okay. So if the object, the neighbor object, let's say, is correctly aligned with the object below, so that it's not flipped or rotated or something. So that one is finished. This one doesn't. You need to sometimes try different UV methods. You need to. It's sometimes also trial and error to see which method in Blender of UV unwrapping gives the best result. So mostly the best thing is to manually select your edges that you want to belt, let's say, and then select UV unwrap. Mostly that gives the best results. Also here, when UV mapping, it's best that your object scale is always resetted back to 1, 1, 1. Because you know, once you start scaling an object, it will have a different value than 1. And if you then UV unwrap it, the dimensions will be wrong. Once we unwrapped an object, we just hide it so that we easily know what we've done already. These two are instances of each other, so normally we only have to do one object. Mostly the bottom and the part is always done separate. Because like for example the sphere, when you UV map that and you don't add an edge somewhere, it will just create distortion. It will stretch UV, so that's not a good thing. So you should always keep your UV of every part of the model the same dimension as how it is in real. So we're going to UV map this one without the center point, and I will show you what the problem will be. When I unwrap it, it's not correct. The dimensions is not correct as the object you see, so it would be squeezed. So the first problem is I want to reset all the scales to 1, 1, 1 of these objects, but they're instances of each other, so it will not work. So what I have to do is first make them a single user so that they are not connected to each other anymore. Then I can apply a scale. Now it's all 1, 1, 1, and now I have to relink them back together. So make the links again, and then I can continue unwrapping them. So that's a bit of a problem in Blender, that you first need to make them all single user again and then relink them so that they're instances back. And now we can continue UV mapping. So this was the old result, and now with scaling applied, this is the new result. So this is the correct dimensions of the UV map. So now we only need to do it a few times because all the rest are instances. See, these are all also changed. So imagine if they were not instances, you had to UV map all of them separately. So we can now hide these ones and UV map the next object. So you need to think, like I told you before, to think about front, up, down, and split them up like that. Because there were instances, some of the sides don't completely fit, so you need to just do some rescaling in some parts. So UV mapping can take a lot of time. It's a very important step in modeling because if you have an object without textures, it's just a plain object. So it's not, you cannot use it for any game, you cannot use it to present it online unless you would just put one color material on it. You will not be able to apply any normal mapping on it, so it's very important to have a good UV layout. So now that all our objects are spread everywhere a bit, we have to put them all in this gray 2D plane, because that will be our texture later on. So now it's a matter of a puzzle. So, or you can puzzle it yourself, or you have some options in Blender to try to do it automatically, put all the UV maps into this gray square. When you have a simple object, you can do it manually. Manually is mostly the best way to do it, because you can create your own layout, how you think it will be easy to later on texture it. If you have a very complex object, you can always try to do it, let it do automatically, and see if you're happy with the result. So a very important thing in UV mapping is also make sure they don't overlap, because you will later on give them a color, material, a normal map, and if two objects overlap each other, they will get the same texture, the same normal map, and that will create problems. So always make sure they don't overlap. What is also a lot of work is this layout to use as much of the texture as possible. The less open space you have, so when there's not an object using any of that part of a texture, it's a waste. And so try to really scale things up and down until you used the full texture space. So you see this is a lot of work, especially if you have much more complex objects. But there is another way in Blender to pack islands automatically via the pack island function. And then what Blender does is it just uses kind of algorithm to place it automatically, what it thinks is a good layout. What you see here, the texture is not used so great, the texture space, but you can still manually scale and optimize it. But I think it's a good start to work on. The next step is to export this as a texture so that we can use this in Photoshop to create our textures. So we just create a folder next to our Blender file that we save, textures. Save this as a UV name. .png in this case, you can choose whatever format. Important is that it should be a square texture. So we use in this case 2048. This doesn't need to be the final resolution, but it's good to always use a high resolution as starting point, and then you can still downscale later on. So we will go to Photoshop now, because we are going to create the textures. You open this with Photoshop. You can edit it with any photo program, like the free version of GIMP. We create just an empty folder and name it diffuse, so later on when we find good textures we will place it in that folder. So now let's go to textures.com, previously CG textures. Here you can find textures from any kind. So in this case we are at the wood section, and let's see what we can find as useful textures. Some textures are tileable, some are not. In this case we don't need any tileable textures. It should be something which has a bit of contrast, a bit of nerves, the nerves of the wood. The color is not that important because you can change the color in Photoshop any way you want. So if you look at specific color, ignore that, just look at the structure, and then later on you can change that color. So we just download the few textures that we think can be used. And download the high enough resolution. Maybe look for one more. We're looking for wood that is being used also. So not too clean, with some character. I think we have enough downloads. So let's copy our downloads to our Blender location texture folder. Paste it in there and then drag this into Photoshop. And let's maybe start with this texture. This looks like the best texture of the two that we downloaded. So let's just duplicate this layer to our existing UV texture and manipulate this a bit so that we can use it onto the model. I just scale, rotate, adjust as necessary. We just duplicate this so that we have a filled square of texture. Photoshop is really easy, so it's not a big thing to learn it. Can be very advanced, but in this case it's really simple. Voila, I think that's fine. Let's save this so that we can load this into Blender. Just name this as diffuse texture. Okay, that's that. Now we can go into Blender and load that texture that we just made. We create a new slot in the texture folder. Link to the diffuse texture that we just made. Now you don't see any result because we're not in texture mode. So we have to switch to texture. It's still not visible because the textures are not linked to the UV. So you see in the left they are empty, and now when we select in the UV image the right texture, it appears. So let's now observe our texture on the model. Here and there, like this side is not correct, because one side of the wood structure goes up and the other side on top goes horizontally. So we can make some changements here so that the orientation of the wood structure is in the correct way. I think that looks better. The top doesn't look that great, so we'll also change that. Rotate this 90 degrees. Make sure it doesn't overlap. So let's just place this a bit better. Like that. I think that's more realistic. Yeah. The direction of the wood on the triangles can be better. Also do that for the bottom. That's fine. Let's just save this. So now you see everything is still straight. So we have to do something about that, because in the real world nothing is 100% straight. It doesn't look natural. So what we can do is we just add some more detail into the wood and then make some deformations in such a way that it's more like a real object. We don't need to care about the amount of polygons, because first we're making the high polygon. Later on we can remove again these extra created detail for the low polygon version. So first ever add some rings of edges so that we can translate and scale these later on. Okay, so now we can add a displacement modifier to make it a bit random, translate it a bit randomly everywhere. So the displacement modifier uses a texture together with a strength. So we first reduce the strength a bit, and now we're going to change the texture to clouds. Most of the time I use clouds because that looks like a nice random gives a nice random shape. And now here the strength, reduce it a lot because mostly it's way too high. So now with just a few steps you can already see there's everywhere a bit of deformation. Don't overdo it, of course, because it's not a chair which melted or something. It just so this is a bit too high. So it's just a matter of playing with the size of the displacement texture and the strength of the texture. And it looks already much better. Before and after. Do it a little bit less. Yeah, I think that's good. Still not enough, but because this is applied on the whole body, this is first very subtle. And now we can use the proportional editing sphere to add some local deformation. So here and there just translate a little bit, not only in one axis but a little bit in every axis, because that's the way it is. You have to remember this is the high polygon model, so for example also in a high resolution presentation or an animation, this can be rendered from very close, so there should be a lot of detail also when you go closer to the model. If this model is used for very far, yeah, then you don't really need to do all this work. But we're going for the high quality version, so just a lot of manual work, but at least now you have control over it because of the displacement texture. Yeah, it's difficult to have that right on the whole model, so better to use that for small details, small displacement, and then you just manually do the bigger ones. You can always also have multiple displacement modifiers, one with fewer detail, one with higher detail or bigger displacement. So you can always add as many modifiers as you want. Okay, we're going to fast forward this because I'm going to do this on all the parts of the chair. So I'm going to skip a small part. So now we have our updated model. Let's just save this again to another Blender file, because you know, the more you save the better, and it's always good to save at specific moments, also when you've finished some stage of modeling. The next step is creating the texture for the bumpiness, so the structure, and also maybe create also a texture for some more displacement later on. Let's first start with adding some bump, because now it's very shiny. There's no structure inside, it's just smooth. So let's just duplicate our folder that we made of the wood and use the same structure in black and white, because bump only use black and white, to create some grooves into the wood. We'll also duplicate the bump map to use still a bit more as displacement, because maybe the dark grooves we can also use it in our displacement slots to add some more real detail, because anyway we're working on the high polygon model. So let's save this as a JPEG for displacement first, and let's later on save this then for a bump. Let's do this now, so that we have already all the textures that we can use. A bump, okay. Now let's load in the texture. Let's first do the bump map. So this, we have to disable the color and enable the geometry normal slot. Let's put it very low, because mostly it's always way too high. So look, this is the result. It already has some structure. Change the material, way less specular. Wood doesn't reflect so much, so that's already looking more realistic. I'm already pretty pleased with that result. But it still looks a bit smooth, so maybe we can higher it a little bit, like that. It's a matter of playing, trying out. Something is good to try out high values and then reduce it. Intensity, the sharpness of the shininess should not be too high. Let's save this out. And now let's add a displacement texture. Disable color, we don't want to use it for color. Let's just also name our textures, so that we don't get confused on what texture we're working on. So now that we have the displacement, let's do something with that. Okay, so let's add another displacement modifier. Last time we used the cloud texture, this time we use the texture that we already made, this displacement texture, and we change the texture coordinates to UV and adjust the strength to whatever you want. This is probably a bit too high, but I already like it, because it again adds much more detail than we had before. So just make sure it doesn't look melted. Like here we see, when you don't see the texture but only this solid color, you better see the geometry of the displacement. So this is too sharp, because you know, in black parts it will push inwards, white parts will push outwards. So let's just make this a bit more blurry, so that you don't have too much variety of displacement. So let's resave this. Okay, reload it, and that looks better. Yeah, okay. Not too much, not too little. Let's see the strength, if we can do anything more with that. A little bit of more detail. That looks pretty good to me. Okay, so let's create another texture, specularity map. Specularity is also a black and white map, to show where it should be shiny and where it should not be shiny. And you can use it first of all as a black and white map for the shininess, but also for the color. So you can use it for both purposes. So here we use first the intensity, but the intensity is not correct unless you use it also for the color. So you see, once you enable the color, it becomes already better. So like I said, first it looks at the black and white image for the intensity. The whiter, the more the specularity. So let's first reduce that. It's too bright, so it's too much shininess. So you can change it to something much darker so that it doesn't shine so much. And you can create a different texture with how the color looks of the specular. But we will just use in this case the same texture, so when we enable color it looks already much better. You see now whatever we change in the specular slot, it doesn't change, only the hardness of the material still changes a bit. Because our texture overrides the intensity. Again, the hardness, you can also create another black and white texture for that to control that. So you can really control everything with textures. So let's make some lights to see better our texture in different directions. So you can also play a bit with the intensity value and even leave the color value empty or slot empty. So you can, if you want, create a good result with just the specular intensity. For example, like this. Now if you would enable the color, it's almost completely diffuse, which is too much. So in this case, well, we can just disable the color and just leave the intensity very low, like this. Let's maybe just do one more thing, change the hardness to make it a little bit more hard, a bit more concentrated, like this. Yeah, this is good. Okay, so let's save this, and now we can start modeling our low poly version. Can duplicate just the model. Let's rename it. Rename our models because we didn't rename anything yet. There's the chair low poly, then the other one the chair high poly, so that we never get confused on which model we're working. So let's rename this. We keep both chairs in the scene because later on we will make a normal map from the high poly. So let's now start working on the low poly. Let's start disabling the modifiers, because the modifiers are the ones who create a lot of polygons. So displacement in this case doesn't do a lot when you have few polygons, so we'll probably not use that. But you see already without the modifiers it's already much more low poly. Let's just see what the displacement map exactly does to the low poly version. Okay, so there's a bit of difference with and without the displacement. So let's just apply the displacement that the shape is deformed, but remove the subdivision surface. Now let's rename this and save it. Okay, and now we can just start reducing the amount of edges, vertices, polygons. Now we're adding more detail to the curved part of the chair, because anyway this is low polygon, and sometimes if the curved parts of your model is very low poly, it's the first thing you notice, and that's really annoying. So it is better to add some more detail on the curved parts and not on the straight parts. So we have actually the high polygon on top of the low polygon. You can see that somewhere on the faces that it's overlapping. So I see clearly then where my model is different in my low poly version compared to my high polygon. So it's always good to have both of them on each other so that you can see where you still need to manually adjust a bit. Because later on when you will use the normal maps of the high, you should not have too much difference in both models. So that looks pretty good. Of course these edges can be removed because we will get the normal information of the high polygon. Here the smoothing is not so important, so it can look ugly like this. The normal map of the high polygon will fix this again. So all these extra edges that I created for the high polygon model is not necessary anymore. And of course this will help the performance of the low poly model in a computer game, for example. Here also there's a lot of edges which we don't need at all. So let's just remove them. You will be really amazed how normal maps can add detail to a very, very low poly model. If you want, you can still optimize this even more and reduce the edges by half, but I think today's quality of games, it can handle this amount of polygons for a chair. So for me this is fine. You can go as far as you want in optimizing this model. Here and there where you don't see a lot of differences in the edges next to the other one, you can just remove them because it's a straight line. So like these edges, they're not doing a lot because their neighbors are actually more or less the same, so you can just remove these ones. So creating a low polygon is not that much more work. Of course it depends on how complex your shape is of the high polygon model, but in this case it's a few minutes you can already create your low poly model. And that's what I meant with understanding in the beginning. Before you model your high poly, think about later on when you will reduce it, the less polygons you created the model with, the easier you can create a low poly version. So you can already save half of the work by thinking about it in the beginning. Like not collapsing modifiers like the subdivision modifier, don't collapse that, otherwise you have to, you will have a lot of work. So now we're going to create the normals. So bake the high poly normals on the low poly model. How we do that? We can split our view, we can go to UV image editor and we create just a new texture, an empty texture called normal, for example. Put the correct texture resolution in. We used 2048 by 2048, so we'll also use the same resolution for the normal map. Okay, so that is made. So now we're going in the low poly model and link that to the empty, the normal texture, which is still black. What you now need to do is select the high polygon first and then in the end the low polygon to bake the normals. But what we're going to do first is duplicate the material of the low poly because they still share the same material with the high poly, and remove now the bump and displacement because the bump and displacement of the low poly will be taken from the high poly model. So if the high poly has a normal has a bump map on it, it will also bake that in the normals together with the shape of the high polygon. So we can remove these, also the displacements. We can still keep the specularity because that doesn't change anything to the structure of the chair, it's just a material setting. So now that this is made, we can go into edit mode of the low poly chair. The normal is selected on the left. We can put a resolution, but I don't think this matters in this slot because we already made it normal map texture of 2048. So I think whatever you put in there doesn't matter. So now bake, we have to put normals. We also have to enable selected to active because we selected first the high and then the low poly, and now it will actually bake the normal map. Voila. So now this normal map contains the shape, the difference in shape, plus the bumpiness of the material together into one, because you cannot combine a bump map with a normal map. Everything needs to be in one normal map. So this is already a good bake. So now that the bake is succeeded, we have to just add that normal map to our low poly model. First we have to of course save the image because we didn't save the image yet. The image was just created in Blender itself, but it was not saved to the hard drive. So let's just call this normal. It can be just a simple JPEG to save some space. Save the image, and now we load in that normal map that we just rendered from the high poly. Voila. And now of course we have to select that this is a normal map. So first you enable in the geometry, but also select normal map from image sampling. And now it has the normal map applied to it. So it will render with the normal maps of the high poly model. So now we only see our low poly model, and what you can see is the normal map active on it. So all the the ornaments, it looks like it's the high poly model, but it is not. We just add some ambient occlusion to show into small corners a bit more darkness. So you see in the edit mode, you see the polygons, it's very low, but still it has a lot of detail, and the normals look okay. So that's because of that normal map with all the information included in a very efficient way. So that's it. It's actually a very simple method as long as your UV map is good. So look here, this is the difference. It's a very big difference between the shape without the normals and the one with. So here you see again. So this is all the light information of the high poly model. Together with the bump map that it was applied on. And still we have all our original models saved, we have our process saved. So this model is very easy to change still. So this way of working is crucial for creating content online, publishing for games, etc. So let's just save this. And what you can do here, you see on the left in the normal map there are still some small problems, but that's just because the mesh, the UV ends at these parts, so they overlap with the other meshes, like for example the vertical support and then a horizontal support. They're a little bit into each other, so that's why these rings are created, but you don't see that visually. So you can just move the lamp around to see how it's reacting, how the normals are. But globally I think it's a pretty good result. So even if you have just one plane, and in the high poly you can brush whatever you want on it, detail. If you then bake it on a flat plane, it can still have a lot of detail. So what I will do now is just put the low poly and the high poly next to each other so that you can see or not see the difference. So can you recognize which one is low and the high polygon? The less you see it, the better you did your job. But it also depends on the format. If you have to produce something for mobile, yes, then you need to very much reduce it, so you will always see a difference, but the job is to minimize it as much as possible. And what I was talking about the curve of the back, so it's important to add a little bit more detail in the low poly so that you don't notice from the outer shape of the model, the contour lines, that it's a low poly model. So here you see now with the wireframe enabled how much more polys the right has compared to the left, and still they look pretty much identical. So what we can do now is split our screen and check it out how it is when you would render it in the live rendered mode in Blender. So here this is the result when you would render it in a viewport, how the result would look like. But like you see, it is not so much difference than in our viewport on the right, so it's pretty accurate. So yeah, it doesn't add so much. So what we have to do, very important, is save our Photoshop file with all the original layers and textures. So save this so that you can always go back to the original files, close everything. And what we can do is fix a bit of the normal maps to make it a bit more clean. So we can just use the clone stamp, click somewhere where we want to copy it, and then just retouch it. Like that. Like I said, probably you won't even see it on the model, but it makes it a bit cleaner. So once we finish this, we can just go back to Blender, reset the position of the chairs so that they're in the center, and voila, we have our low and our high poly version ready to be used. That's the end of this tutorial. Thanks for watching.